Become the pupil with maths expert Wendy Fortescue-Hubbard and see a simple way to start off with fractions.
Fractions is one of the topics in mathematics that many people find very difficult. This is quite often because when they first started learning about fractions, they never really got the chance to rip up pieces of paper. Chocolate, chocolate, chocolate. Half, a half, and a half. How can that be? I expect you were always taught that when you had a half, there had to be two identical sizes. But this is a half of a large bar of chocolate. This is a half of a medium-sized bar of chocolate. And this is a half of a small-sized bar of chocolate. When you're talking about fractions, you're talking about a part of a whole, which means that when we define our whole could be quite big or our whole could be quite small. Oh, this isn't the maths lesson you want to do before lunch. Now let's have a look and see how that works when we use paper. Here I've got one whole piece of paper. That's my whole. I'm going to take that piece of paper, and youngsters in class need to do this as well, and I'm going to divide it into exactly two. The two pieces need to match. And what I've got now is I've got 1 out of 2 pieces. 1 out of 2 pieces. What I've got is I've got my 1 whole 1 and I've divided it into 2 equal pieces. My 1 whole 1, I've divided it into 2 equal pieces. My 2 parts make a whole. There's my halves. Okay, let's take a different colour piece of paper. Let's see how that works this time. This time I'm going to take my 1 whole and I'm going to divide it into 3 equal pieces, and they need to be exact. Each piece has to be identical to the other. 1, 2, 3. Okay, can we name each of these pieces? How many pieces? 1, 2, 3. I've got 1 out of 3. I've got another out of 3. And my last one out of 3. 1 whole 1 divided into 3 equal pieces. A third. 3 thirds make up 1 whole. So where can that take us? Let's have a look at what happens when we have more than 3 thirds. So we have 1, 2, 3 pieces. That's 3 thirds. 3 thirds are 1 whole 1, and we can see that fits exactly on top. So what have we learnt so far? Well, we've discovered that you call a fraction by the number of pieces that you have divided that whole shape into. Here are some pieces, Blue Peter style, for us to look at. I'm going to spread them out to make 1 whole. Let's check that that is definitely 1 whole piece. 1 whole. So what is the name of these fractions? 1, 2, 3, 4, 5. So the name is 1 chopped into 5. 1 chopped into 5. 1 divided by 5. 1 divided by 5. And 1 divided by 5. 1 whole. What happens if we have more than 5/5? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I've got 11/5. 11/5. In mathematics, when we have the top number being larger than the bottom number, we have a name for that, and it's called a top-heavy fraction. Another way of writing 11/5 is to look at how many whole ones we have in this 11/5. So we need to have a look again at our whole pieces of paper. If you remember, for one whole number, we need to have 5/5. 5/5 makes 1 whole. There we go. 1. And can I make another one? Let's see. 5/5. Yes, I can make another one. So what I've got is 1 whole one, 2 whole ones. But I've got a fraction left over, 1/5. So here we've got 2 whole ones and 1/5. 2 whole ones and 1/5. This, in mathematics, is called a mixed number. We have the whole part with the fractional part. So you can see that we can write 11/5 as 2 and 1/5. Let's have a look at 3 and 2/5. Right, first of all, we need to have 1, 2, 3 whole ones. 3 whole ones. And we've got 2/5 at the end. If you remember, for 1 whole one, we have 5/5. Which is going to be true for each of our whole numbers. So how many fifths have we got altogether? We've got 5/5 here, and we can write that down. Plus another 5/5 there, another 5/5 there, and our 2/5. So altogether we've got 5, 10, 15, 16, 17 fifths. So 3 and 2/5 is 17 fifths as a top-heavy fraction. 3 and 2/5 is 17 fifths as a top-heavy fraction. So where has this initial journey into fractions taken us? First of all, it's helped us to understand, using the chocolate, how important it is to define how big our whole is to start with. Then we've looked at dividing a whole into equal sized pieces, and then how we can take the number of the pieces to make back into a number of wholes. And through that journey, I think that we've learnt that the bigger the number at the bottom, then the smaller that part of the whole is. Clever, isn't it?